One of the first things we're going to do when we meet a new family of functions is to ask, what does its graph look like? And part of the reason that we want to consider a base function composed with linear stuff is that composing with linear stuff does not change the basic shape of the graph. It can move it around, it can stretch it, it can squish it, but it doesn't change the basic shape. So this is a pattern that we're going to see repeatedly. First, we're going to say, well, what is the base shape of the absolute value function? Then we're going to say, okay, when we meet a new absolute value function, how do we figure out where it is and how it's stretched and squished? So here we're taking f of x as just the absolute value of x. So that's just the base absolute value function. So when x is -3, f of x is the absolute value of -3, which is 3. When x is -2, absolute value of x is the absolute value -2, which is 2. When x is -1, f of x is the absolute value of -1, which is 1. X is 0, f of x is the absolute value of 0, which is 0. X is 1, f of x is the absolute value of 1, which is 1. X is 2, f of x is the absolute value of 2, which is 2. X is 3, f of x is the absolute value of 3, which is 3. So all of these are going to be pairs on the graph. -3, +3, -2, +2, -1, +1, 0, 0. And then we have 1, 1, 2, 2, 3, 3. And I think that what we're seeing here is some kind of a V shape. So in the positive direction, we're just going to have, it's the same line as y equals x. Right? As x gets bigger, its distance from 0 gets bigger at a constant rate. In the negative x direction, I think we're going to have the same line as y equals the opposite of x. So as x becomes a big negative number, the absolute value gets bigger at a constant rate. And this is what's always going to happen with an absolute value, right? We're going to take the absolute value of negative stuff, that's going to be positive numbers. The absolute value of positive stuff is going to be positive numbers. And at some point in the middle, we're going to have the absolute value of 0. And at that point where we have the absolute value of 0, our graph is going to turn around. The graph of an absolute value function will always be either V-shaped like this or like this flipped upside down. And so we're going to have some turning point, and then we're going to have 2 rays coming off that turning point, which means that all we need to graph it is to know where this turning point is, and then know what direction each ray goes. And that gives us a procedure for making one of these graphs. First, we figure out where the point of the V is going to be. That's where the input of the absolute value is 0. So the stuff inside the absolute value is 0. Then we'll find one point with integer coordinates to each side of that point. And finally, we'll fill in the sides of the V shape. As an example of this procedure, let's graph the function f of x equals -3/2 x minus 1 plus 4. So the first thing we need to do is figure out the point of the V shape. So that's where x minus 1, the expression inside the absolute value, is 0. In other words, that happens where x equals 1. I'm going to put x equals 1 as the middle input in this table of values that I'm making. To figure out the value of y that goes with that, I'm going to take f of 1, which is negative 3/2 times the absolute value of 1 minus 1 plus 4. 1 minus 1 is 0. Its absolute value is 0. Negative 3/2 times 0 is 0. So that just comes out to 4. Now, to find points with integer coefficients, I notice that I'm multiplying by 3/2 after I take my absolute value. The denominator is 2. So I can get a point that'll have integer coefficients by subtracting 2. 1 minus 2 is negative 1. Or by adding 2. 1 plus 2 is 3. When I plug those in, my y value is going to be negative 3/2, absolute value negative 1 minus 1 plus 4. So that'll be negative 3/2, absolute value negative 2 plus 4. That'll be negative 3/2 times 2 plus 4. Negative 3 plus 4 is 1. When I plug in 3, I'll have negative 3/2, absolute value 3 minus 1 plus 4. 3 minus 1 is 2, so negative 3/2, absolute value of 2 plus 4, and that's negative 3/2 times 2 is negative 3 plus 4, so that's 1 again. The point of my v is going to be at 1, 4. That's up here. And then my 2 points, one on either side, I've got a point at negative 1, 1, and I've got a point at 3, 1. And then I can draw the graph by taking rays, starting at the point of the v, and going out through those 2 points on either side. And this is what my graph ends up looking like.